Trouble you find on the test stand may well prevent trouble when it would have more serious consequences. Here it results only in the loss of a little fuel, a washdown of the area, and the possibility of returning the engine to the maintenance hangar for more work. The portable universal jet engine test system consists of two major components. The test bed assembly, securely jacked, tied down, and leveled, on which the engine to be tested will be mounted. And the control cab fuel supply stand assembly with its power source. Refueling of the fuel tank follows immediately after each test. The operator in charge will conduct the test from the control cab. Special adapters are kept locked in the cab between tests. At least 2 crewmen will serve as inspectors during the run-up. While the system can be moved from place to place, a site, once selected, is generally used for a considerable length of time. A remote area is selected due to the undesirable noise factor. The site should be located on a firm, level surface, elevated sufficiently to afford good drainage, and constructed of a material to minimize foreign object damage. One of the requirements for the setup is a holdback facility that is especially constructed in concrete to withstand tremendous thrust loads. To keep the engine from becoming airborne when power is applied, the holdback cable from the anchoring facility is connected to the engine adapters. The test bed assembly is positioned so the prevailing wind will be into the intake. There should be a distance of 40 feet between the test bed stand and the control cab unit. An angle of 15 degrees offsets the test stand from the control unit. This not only sends the exhaust out at an angle away from the control cab, but sets the engine so that if turbine blades should break during the test, they would be thrown out at an angle away from the cab. This engine is a J-79, used in high-performance aircraft, such as the F-4 or the A-5. While at sea, jet engine maintenance includes complete procedures and equipment for running up an engine on a test stand. Outside or inside, while the environment may vary greatly, knowing how to operate one type of jet engine test stand is good background for work on all of them. Instrument dials and switches in the control room of a permanent installation differ from the portable cab dials and switches in type and placement. But the general procedures and the purpose of the tests are the same. From the line shack, the yellow sheet file is delivered to the unit maintenance office, where the information is copied onto a work order. The power plant chief will assign a troubleshooter to look at the aircraft. The plane will have to be towed into the hangar and the engine removed, for the only way you can work on an engine at the place where the broken spray bar is located is to have the engine out of the aircraft. This engine will be run up on the test stand before being reinstalled in the aircraft. A run on a test stand is in order, following a repair to an engine for troubleshooting of malfunctions that cannot be isolated with the engine installed in the aircraft, and after a major inspection. When an engine is ready for the test stand, the adapters used to remove the engine from the aircraft are replaced with adapters that are used to fasten the engine to the test bed stand. The engine never is run on the test stand unless a bell mouth assembly has been installed. Support brackets are attached at the sides, top, and bottom. After the intake has been inspected for foreign objects, the bell mouth, fitted with a screen to prevent any material from being sucked into the engine, is then lifted into place and secured. The engine to undergo the test is now ready for the connections with the control unit. The operator checks that all controls in the booth are in the off position. First, the fuel system hookup. There are 3 basic connections by Cannon plugs, 3 vibration pickups, and 3 bleed air manifold connections. The throttle control is checked for positive shutoff in the 0-degree position and for proper operation and condition. With the engine secured, the bell mouth installed, and all connections made, it is now time to pick up all tools and materials and make the comprehensive pre-start inspection. All tools and equipment are stowed and the area policed for foreign objects and excessive fuel spillage. The operator conducts the inspection in accordance with safety and operational checklists. At least 2 CO2 bottles are required in good condition. Up to this point, all the action has been concerned with the preparations for the test and in making sure it is being done according to safety requirements. The pre-start inspection now includes an actual test of the engine when fuel pressure is applied to the system. Fuel lines can now be inspected for security, abrasions, and evidence of leaks. Special emphasis is put on inspection for leaks, as this is a safety precaution. When the operator is satisfied with each item of the pre-start inspection, he signals for his crew to attach the air starting unit, and he checks to make sure all switches are on and that the throttle is in the off position. Pre-start motoring of the engine serves both as an inspection phase and to prime the engine systems. With the ignition switch off and the throttle at 0 degrees, energize the starter air valve. At 1,000 RPM, 14%. Advance the throttle to the 113-degree position. When fuel flow reaches at least 500 pounds per hour, or when 30 seconds have elapsed, chop throttle to cutoff. And check that fuel flow drops to 0 immediately. Continue to motor for 5 seconds and then discontinue starting air. Throughout this phase, crewmen check for fuel and oil leaks. Then all instrumentation is checked for security. During engine coast down, listen for unusual noises and normal draining. Normal noises during coast down include clicking and clacking of compressor blades and turbine blades and gear noises. Allow the engine to drain for 30 seconds. If no leaks or malfunctions are evidenced, steps are taken to light off the engine. But first, check the emergency shutdown button. This would shut the engine off, but not right away. For immediate shutdown, chop the throttle to cutoff. Energize the starter air valve. At 6 to 8%, turn on the engine ignition system. At 11 to 13%, advance the throttle to idle. Check for oil pressure rise. And note the maximum exhaust gas temperature during the start. Light off should be within 15 seconds after the throttle was advanced to idle. The ignition is cut after light off, and instruments are checked for readings, indicating a good start. At 48%, discontinue starting air. With the engine running at idle, the crewman checked for leaks, and the operator notes instrument readings as per the operational checklist. Nozzle area, oil pressure, RPM, idle EGT, fuel flow, and vibration readings. The operator always signals the crew before making power changes. From idle to 86%, to 100%, then to afterburner. Hold it. Now to afterburner. In acceleration-deceleration checks, the operator tries to get a malfunction. Acceleration time from idle to military should be approximately 5 seconds. For the afterburner check with a throttle in military, advance to minimum afterburner. Check for smooth light off and record instrument values. Advance throttle to maximum afterburner and check for smooth thrust increases. Check meter for correct thrust indication. Retard to military, checking for smooth switchback. Then the final afterburner tests. It is important that during shutdown procedures, the throttle be held at 80% for from 3 to 5 minutes. This cools the engine. Holding it at idle momentarily cools the tailpipe. Then cut off. Check the coast down for normal drainage and noise. The operator will record the time from cutoff to the full stop by the compressor. The post-run safety checklist includes all switches off, all fuel valves off, and the tailpipe inspected for residual fire. An engine that has been run up on a test stand is going to perform correctly when installed in an aircraft. The high power turn-up is a test of installation procedures and of the aircraft instruments. The test stand can eliminate several days' work that would be involved if it were necessary to pull and reinstall an engine several times. Operators of the mobile universal jet engine test stand have good basic background for operation of test stands on shipboard and those that are permanent installations. Use of and adherence to the procedures and safety requirements will assure maintenance personnel that when they install an engine in an aircraft, it has been thoroughly tested, capable of functioning in operational flight.